Did you know that the longest mountain chain on Earth is actually in the middle of the Atlantic Ocean? The Mid-Atlantic Ridge splits nearly the entire ocean from north to south. Mid-ocean ridges form at the boundary between the oceanic plates that are moving away from each other. The formation of these ridges is part of a process called ocean floor spreading. During ocean floor spreading, hot magma from the mantle, fueled by convection currents, pushes up through the cracks between the oceanic plates and solidifies to form new crust. It's important to note that spreading does not occur at a uniform rate as implied by the student models. Furthermore, faults that cut across the ridge break it into chunks. These chunks spread apart separately and may move at different rates. Because of this, mid-ocean ridges are often zigzagged. In Activity 7, students model ocean floor spreading and relate their observations to the formation of mid-ocean ridges. They model the separation of crustal plates and observe what happens at the gap where the plates separate. This activity will take about 40 minutes. The vocabulary introduced in this activity is ocean floor spreading. For this activity from the kit, you will need the plate puzzle pieces from Activity 6 for each student. For each team of 4, you will need the 2 wooden blocks, a plastic tray, and the model of the Earth's crust from Activity 2. For the class, you will need 2 bags of flour. In addition to the kit materials, you will need to supply a spoon, mixing bowl, newsprint, tap water, and the world map. Mix flour and water until the mixture becomes the consistency of thick batter. Then pour the batter into the trays until it becomes about 1 centimeter thick. This activity begins by having students retrieve their puzzles used in Activity 6. The students will be directed to reassemble the puzzle pieces and locate the Pacific and the Nazca plates. And once again, they are asked, where are these plates located? And Kathy, probably what they would say is?
Beneath the Pacific Ocean.
Okay. And what happened at the boundaries between these plates?
Well, last time we noticed that when we moved this in the direction of the arrows, that we ended up with this gap.
All right.
Between plates.
Do gaps exist on the Earth?
Not really between plates.
Okay. We can conduct an experiment with another model of the Earth in order to solve the mystery of the gap. Each team of 4 will need the following: newspaper to cover the work surface, a tray of batter, and 2 wooden blocks. Kathy, I'd like for you to place the blocks on the batter next to each other. Okay. What does the batter represent?
The batter represents the magma that's on the mantle.
Okay.
That's in the mantle.
In the mantle, okay. And what do the blocks represent?
They represent the plates as they rest on the crust.
Okay. Imagine that the blocks represent the Pacific and Nazca plates. Where do these plates meet?
In the Pacific Ocean.
Okay. Now, what I'd like for you to do, Kathy, is just gently move the plates apart about 1 centimeter.
Okay, that's about 1 centimeter, I think.
Then I'd like for you to hold the tray on the palms of your hands. You put your hands down there. Good, all right. Now, what I'm going to do is I'm going to ask you to gently push up, and then I'm going to just resist your pressure up, and let's observe what happens between the 2 blocks, which represent the plates, okay? All right. Ooh, look at that. Okay.
Oh, it comes up between the blocks.
All right. What happens to the batter? It comes up. What caused the batter to fill the gap?
I think it was from the pressure that by pushing up from the bottom.
Okay, so you can see as it fills the gap. What might be happening to the boundaries at the plates as the plates are moving apart?
I think it must be filling in with magma.
It looks like it is. Students have seen evidence that when liquids cool enough, they can become solids. Invite the students to suggest some liquids in their everyday world that turn to a solid when they are cooled. For example, they might mention pudding or ice cream. Students may also recall working with butyl stearate in Activity 5, which turned from a liquid to a solid when very cold water was added. Kathy, what covers the Pacific and Nazca plates?
The Pacific Ocean.
Okay. And what do you think happens when hot magma coming up through the crack between these plates meets cold ocean water?
Well, I think when it cools off, it probably hardens.
Okay.
It turns to a solid.
Yes. What do you think happens to new rock beneath the ocean floor after it hardens?
Well, I think it then kind of builds up and becomes part of the oceanic crust.
Okay. What do you think would happen if the plates moved slowly apart and magma kept coming up through from below?
Well, I think it might start piling up on top of it, one on top of the other, and build up on top of the other and cool and harden.
Okay. Some students might wonder what would happen if magma rose faster than the plates spread apart. What we're going to do is I'm going to ask you to move the blocks apart about 1 centimeter.
Okay.
Okay. Now, I'd like for you to pick the tray up again. I'll hold it, and you put your hands underneath the tray, and we're going to repeat the process.
Okay.
This time. Last time you pushed up and I resisted. This time what we're going to do is you're going to push up, but I'm going to push down. So we'll see that there is greater pressure. All right, let's try this.
Oh my gosh, look at that.
It's really welling up over the sides, isn't it?
It sure is.
Okay. How can you relate what is happening to the model to what happens on the Earth?
Well, it looks like, again, it's piling up. It's maybe even building. We kind of saw some overflow there onto the side that added to the crust, but it also piled up. Maybe it kind of starts turning into a mountain.
Okay. What would happen if the magma continued to pile up?
On top of each other again, it would get higher and higher and maybe become one of those mid-ocean ridges.
Okay. Ocean floor spreading is the process that was modeled here. This is the process by which new ocean floor is created. Underwater mountains form at the boundary between plates that are moving apart. Kathy, imagine that this is part of an underwater mountain range. What type of mountain ranges form on the ocean floor?
I think we call those mid-ocean ridges.
Okay. Let's look at a world map. Do you see any mountain ridges?
Oh, in fact, a lot of these lines that you see on the maps, this is a Carlsbad Ridge, Central India Ridge. I see a Mid-Atlantic Ridge close to North America.
Okay, the Mid-Atlantic Ridge, which is an underwater ridge, forms the longest mountain chain in the world. It goes from way up here all the way south. What do you think caused the mid-ocean ridge?
Well, we saw in our model that the magma comes up, it cools, it hardens, and then more magma comes up, cools and hardens, and it keeps building and piling up on top of each other until we have a mid-ocean ridge.
All right. Which of the mysteries then have we solved?
Well, I think we solved that mystery of the gap.
Okay. The solution is that as plates move apart, magma from the mantle wells up into the gap in the Earth's crust and hardens as new rock. This process, ocean floor spreading, creates new crust in the form of mid-ocean ridges. The discovery of the mid-ocean ridge helps scientists to understand what is happening at the boundaries between plates that are moving apart. We have solved one more mystery. Kathy, why doesn't the Earth keep getting larger as the plates move farther and farther apart?
I don't know.
Let's try to solve that mystery in the next activity. For cleanup, have the students use the newspaper to scoop the batter out of the plastic trays and into a plastic-lined trash can. Wash and clean the trays and blocks and return them to the kit. Puzzle pieces should be returned to the bags and will be used in Activity 8. The models of the Earth's crust are no longer needed. Guide the students through reading page 8 in the Delta Science Reader.